Unit 6, quadrilaterals and other polygons. Today are kites and trapezoids. Let's learn something new. Objectives. The students will be able to recognize and apply the properties of trapezoids, including the medians of trapezoids. The students will be able to recognize and apply the properties of kites. Oh my. Let's start with trapezoids. Definition of trapezoid: a quadrilateral four-sided figure with one pair of opposite sides parallel. Let's start with non-isosceles trapezoids. Here's their properties. Only one pair of opposite sides are parallel. There they are, marked with the arrow. Of course, that means parallel. Consecutive angles between the parallel lines are supplementary. So the parallel lines are called bases. The other two are called legs of the trapezoid. Consecutive angles between the parallel lines are supplementary. Reminder, supplementary angles are two angles with measures totally 180 degrees. So x plus y is 180 degrees, and a plus b is 180 degrees. And that's all we're going to know from our properties. Here we go. Find the missing value of each trapezoid below. So we know they're parallel. So consecutive interior angles are supplementary. So if I take the 51 away from the 180, measure of angle K is 129 degrees. Do the same thing with the 87, and measure of angle M is 93 degrees. Let's do number 2. We have parallel sides again. One set, that makes it a trapezoid. Let's see, 180 minus 31 is 149 degrees. That gives us measure of angle C. Do the same thing. 180 minus 62 is 118 degrees, and that gives us measure of angle D. Ooh, find the missing value for each trapezoid below. Show all algebra and work. Solve for x. There's our parallel sides. Consecutive interior angles. Those are supplementary. Write an equation. 8x plus 6 plus the 54 equals 180. Combine like terms. 8x plus 60 equals 180. Let's subtract our 60 on both sides. We get 8x equals 120. Divide both sides by 8, and x is 15. And that's our final answer for number 3. Number 4. We're ultimately looking for the measure of an angle. So we're going to have to figure out what x is. Those are parallel. Those are consecutive interior angles. So those are supplementary. But then we're going to have to go a step or two further to get the measure of angle r. So 12x plus 3 plus 7x minus 13 is 180. Combine like terms. 19x minus 10 equals 180. Add 10 to both sides. 19x equals 190. Divide both sides by 19. X is 10. Okay, measure of angle R. We have an algebraic expression for that. 7x minus 13. And now we know our value of x. So let's plug it in. So 7 times 10 minus 13, calculate, you get 57 degrees for the measure of angle R. Definition of isosceles trapezoid. A trapezoid with one pair of opposite sides equal. Those are gonna be the legs. So those are the parallel sides. In the little box for the isosceles trapezoids have the same properties as non-isosceles trapezoids plus these. So the non-parallel sides of the legs are congruent. Already have those marked there. The parallel sides are called the bases. Diagonals are going to be congruent. There we go. That's the best way of marking those. Base angles are congruent. So I rewrote that because we got those diagonals kind of getting in the way. So there we go. We have our bases. And if it's isosceles trapezoid, the base angles are congruent. So I have them marked, the bottom ones with black and the top ones with purple. Let's see, opposite angles are supplementary. So there's another property. We already know consecutive interior between the two bases are going to be supplementary, but now opposite angles like A and B are going to equal 180 degrees. Theorems. If a trapezoid is isosceles, then each pair of base angles is congruent. We already talked about that. Here's a new visual for that. If a trapezoid has one pair of congruent base angles, then it must be isosceles trapezoid. A trapezoid is isosceles if and only if there's a symbol for it that is a biconditional statement. So a trapezoid is isosceles if and only if its diagonals are congruent. So if we know it's a trapezoid and we know the diagonals are congruent, then it's isosceles. If we know it's a trapezoid that is isosceles, then we know the diagonals are congruent. It goes both ways. Here we go. Find the missing value of each trapezoid below. Show all algebra work. Mark your information on the diagram. D, E, F, G is an isosceles trapezoid. And we are looking for segments this time. Segments are congruent. Okay, so we're not looking for lengths. Segment DG, the leg, is going to be congruent to segment EF. Now DF is a diagonal, and the diagonals are going to be congruent if it's an isosceles trapezoid. So segment DF is congruent to segment GE. TUVW is an isosceles trapezoid again. Those sides are parallel. Angle T is congruent to angle U. Base angles are congruent. So I just marked them with a dot. Why not? And that's angle U. That's a pair of base angles. And angle V would be congruent with angle W. Number 7. Let's see here. We're looking for all the missing angle measures. And the quickest one, base angles are congruent, is going to give us that 112. The other ones, we know that consecutive interior angles between the bases are going to be supplementary. So let's subtract the 112 from 180. We get 68, and that's the measure of both angle R and angle S. Find the missing value of each trapezoid below. Algebra, hooray! If MNOP is an isosceles trapezoid, measure of angle MP, that's a leg, is 16x minus 13. Measure of angle NO, that's a leg, is 9x plus 8. And we know they must be equal to each other. So write an equation. So 16x minus 13 equals 9x plus 8. Solve the equation. Subtract 9x on both sides. We get 7x minus 13 equals 8. Add 13 to both sides. 7x is 21. Divide both sides by 7. X is 3. So there's one answer. Now y. Let's look at these. Segment PN, that's a diagonal, is 5y plus 19. And the length of segment MO is also from a diagonal, 12y minus 37. So diagonals are congruent. Let's set them equal to each other. So 5y plus 19 equals 12y minus 37. Let's get all the y's on one side, subtract 5y on both sides. We have 19 on the left equals 7y minus 37. Add 37 to both sides. We get 56 is 7y. Divide both sides by 7. Y is 8. Let's see, if A, B, C, D is an isosceles trapezoid, find each angle measure. Well, those are base angles, and base angles are going to be congruent. So let's set them equal to each other. 2x plus 27 equals 5x minus 12. Let's get all the x's on one side. So subtract your smallest one. Subtract 2x on both sides. We get 27 equals 3x minus 12. Add 12 to both sides. We get 39 equals 3x. Divide both sides by 3, and x is 13. Okay. That is not everything they wanted. They wanted the measure of all the angles. So let's plug it into the measure of angle D. Why, it's on the left. I got it first. Who cares? You could put it in measure of angle D or measure of angle C. They're going to be the same. We know x is 13. Plug it in. Measure of angle D is 53. So both measure of angle C and measure of angle D are 53. The other ones are going to be supplementary to that. So subtract the 53 from 180, we get 127, and that's the measure of angle A and measure of angle B. The mid-segment of a trapezoid connects the midpoints of the legs. So point E is a midpoint, point F is a midpoint. We have the markings to show that length of segment AE is equal to length of segment ED, and length of segment BF is the same as length of segment FC. So point E and point F are midpoints. If segment EF is a midsegment of trapezoid ABCD, then segment AB is parallel to segment DC, which is also parallel to segment EF. The midsegment's parallel to the two bases. What else do we know? Well, the midsegment is the average of the base length. So length of segment EF is the sum of the length of the segments of the bases divided by 2. There are the properties of a midsegment. Midsegment of a trapezoid. Find the indicated length. Show our work. Find the length of segment WX, which is, of course, the midsegment there. Midsegment is the average of the bases. So add the two base lengths and divide by 2. So 27 plus 39 divided by 2. 66 divided by 2. Length of our midsegment is 33. In part B, we're also looking for the length of a segment, but it's not the median. And we have algebra. So much more fun. Write your expression here. 45, the midsegment, is the average of the bases. So the top base is 3x plus 11. Bottom base is 10x minus 12. And if we add those up and divide by 2, we have the average. Let's simplify. So 45 equals 13x minus 1 over 2. We just combined like terms. Get rid of the 2 by multiplying both sides by 2. We end up with 90 equals 3x minus 1. Add 1 to both sides. 91 is 13x. Divide by 13. X is 7. That's not our final answer. We want the length of segment ML. We have an expression, length of segment ML is 10x minus 12. So we're putting that 7 in place of the x, and we're going to get 58. Definition of a kite. It's a quadrilateral with two pairs of consecutive sides congruent. So here we go. We have them marked. We have two pairs of consecutive, right after each other, sides that are congruent. Properties of kites. A kite is a quadrilateral four-sided figure with the following properties. exactly two pairs of consecutive congruent sides. So segment AB is congruent to segment AD. Those are consecutive. They're also marked. Segment BC is congruent to segment DC. Those are congruent in green. They're also marked with two slashes. One pair of opposite angles are congruent. That's those two right there. That is angle ABC is congruent to angle ADC, and diagonals are perpendicular to each other. So, of course, it makes four right angles in there, four right triangles, two pairs of congruent ones. We'll use all that. Heights, examples. Each quadrilateral is a kite. Find the missing value. Show all work. Mark information on the diagrams. So in the prior lesson, we know the measures total in a quadrilateral to 360 degrees. And we have two of them that we know. So 360 minus 85 minus the 43 gives us 232. Now, angle B and angle D are the two congruent angles in the kite. So we can take our 232 and divide by 2, and measure of angle B and measure of angle D is 116. In number 2, measure of angle J and measure of angle L are congruent, so that's 32. All the angles total 360. Get rid of the ones we know, and measure of angle K is 125. Number 3, we are given measure of angle QPT is 37 degrees. Let's see what we're looking for. Measure of angle PTQ. Okay, that's 90. That's simple enough. The diagonals are perpendicular. Let's see what else is left. Measure of angle PQT and measure of angle QRT. Well, measure of angle QRT is the same as the measure of angle QPT, so that's 37. So if we subtract the 37 from 90, because the acute angles of a right triangle are complementary, we get the last angle that we need to know, which is 53. Number 4, we are given measure of angle GGH is 59 degrees. So we know there's another one just like it over there. Those two triangles are congruent to each other. Let's see. Measure of angle GGE. Well, that must be the sum of those two, 118. Measure of angle DEH and DGH. Those are going to be congruent, and they are acute angles of a right triangle. So 90 minus 59 is 31, and that's the measure of the last two angles. Number 5. Let's see, same directions. They have a lot of information that we need to find. I think the easiest one is measure of angle 3 is 90 degrees. So we have four right triangles. That's probably going to help us out. Measure of angle 4 is the same as 65, and measure of angle 7 is the same as 52. So let's get in our 65 and our 52. Acute angles of a right triangle are complementary, so we can find some other ones. 90 minus the 52 is 38, and that's going to give us measure of angle 5 and 6. Those are congruent. If we do 90 minus the 65 degrees, we get 25 degrees, and that gives us both measure of angle 1 and measure of angle 2. Number 6, if WX is 14 and WR is 8, we need to find the length of segment RZ. So that is right triangles, four right triangles in there. The diagonals are perpendicular. Length of segment WX is 14. So length of segment WZ is the same. Length of segment WR is 8. And we need to find the length of segment RZ. We have a right triangle in there. Let's pull it out. Ooh, Pythagorean theorem. Let's go. Measure of angle RZ is the square root of the hypotenuse squared minus the leg squared. Put it into Desmos, and we get about 11.5. It does say round to the nearest tenth if necessary. Another one, number 7, same directions, I believe. Length of segment RS is 10. Length of segment RU is 9. Find the length of segment QS. That's that whole thing right there. RS 10, RU is 9. Right triangle. Diagonals are perpendicular. That's what gives us our right triangle. Pull it out. Pythagorean theorem once again. But length of segment US is on our right triangle. And we want QS, which is going to be double that. So let's do 2 times the square root of 10 squared, hypotenuse squared, minus 9 squared, the leg squared. Put it into Desmos. We get about 8.7. Number 8, finding the measure of angle L. Now those two angles are equal to each other. So let's set them equal to each other. 5x plus 23 equals 8x minus 31. Subtract the 5x on both sides because it's the smallest. We get 23 on the left equals 3x minus 31. Add 31 to both sides to get rid of the minus 31. We get 54 equals 3x. Divide both sides by 3. X is 18. But we want the measure of angle L. So we do have an expression for that. 5x plus 23. Plug in the value we got for x, which is 18. And we get the measure of our angle as 113 degrees. Number 9, we're also looking for the measure of angle. Measure of angle STV. Okay, that's going to be the same as the measure of angle VRS. Now the two that are marked are going to be complementary to each other. So they are going to add to 90 degrees. Let's see, there's our right triangle. Acute angles in a right triangle are complementary. So those two. So complementary angles, everything from day one's fair game to angles with measures totaling 90 degrees. So 9x plus 1 plus 23x minus 7 equals 90. Combine like terms. 32x minus 6 is 90. Add 6 to both sides. 32x is 96. Divide by 32 and x is 3. Not our final answer. We want the measure of angle STV. That is the same as the measure of angle SRV, which has an algebraic expression, 9x plus 1. Let's plug in our 3 in place of x, and the measure of our angle is 28 degrees. Here's just a review of some properties. We haven't gotten to all of these, but I'm sure you know some of them. Square, all the sides are equal and all the angles are 9 degrees. We actually used it a little bit in the last unit. Rectangle, opposite sides are equal and all the angles are 90 degrees. Parallelogram, opposite sides are equal and parallel. By definition, it's parallel. Now the greens arrows mean those two are parallel. The purple mean those two are parallel. If you're writing it on your paper and not using color, you should probably use 2 arrows, double arrows on one of those sets. Let's see, trapezoid is how we call it. Trapezium is in the UK, but 2 sides are parallel, and that's those 2 right there. A rhombus, all sides are equal to each other. Opposite sides are parallel because it's a parallelogram. Opposite angles are going to be congruent because it's a parallelogram. Let's go to kite. Let's see, adjacent pairs of sides are equal. We just covered. We are now at the conclusion of lesson 6.2, kites and trapezoids.